Good afternoon, everybody. Mr. K here. And what I'm doing today is recording a video of me taking the 2019 release math tests for students. What I'm doing is I'm taking the test as if they're taking it themselves, how I teach them to take the test. The strategies he uses, key phrases, what certain things mean based on the context they're in. So hope you enjoy the video. If anytime you need to pause the video or rewind the video, please do make sure you get all the content needed so we're solving these problems correctly. Have your child watch the video, have them write down with their folded paper strategy, each individual problem, see if they get it right. If they are, good work. If not, always rewind so they can get better at it. The only way we get better doing math is by doing it more and more often. Repetition is key. Repetition is key. Same way we learn how to shoot a basketball, same way we learn how to hit a baseball, throw a football, catch it. We got to go outside, we got to practice. Education is the same way. If we're not practicing it, how do we expect our kids to get better at it? All right, so let's get started. It says supermarket has 238 large boxes of cereal. Each large box holds 32 small bags of cereal. How many bags of cereal are in the supermarket? So let's go through and look at what this sentence is giving us. All right, we know we have 238 large boxes of cereal. We know each large box holds 32 bags. And we know we got to find out how many small bags are in the grocery store. So I want to find a total. So I'm coming out right. I'm finding a total. All right. So anytime we got to find total most, we're going to either add or we're going to multiply. In this case, it makes sense to multiply 238 times 32. All right. Now, multiplication, there are different ways you can do it. I teach the standard algorithm. I teach the box and area model. I also teach the lattice method. In this scenario, I'm going to go ahead and use the standard algorithm. Those are enemies I stack it up on top of each other. So I got 238 times 32. So my one's placed on my second set of numbers. So I got 8 times 2, which is 16. Carry that 1. 2 times 3, which is 6, plus 1 gives me 7. And then 2 times 2 gives me 4. I come down for that 5 start on my 3. I drop my 0 in the 1 spot as a placeholder. 3 times 8 is 24. Now I carry my 2. 3 times 3 is 9, plus 2 gives me 11. I carry that 1 over here. And then 3 times 2 is 6, plus 1 gives me 7. After all that is done, I come down, I add. That's 6. This is 11. Carry my 1 over here. 1 plus 4 is 5. 5 plus 1 is 6. And then I got 7 by itself. So I get 716, which is D. All right. Number 2 says Richard walked 15 and 7400 miles and James walked 12 and 9800 miles. How many more miles did Richard walk than James? All right. So it told us how far Richard walked, which was just 15.74, and James walked 12.98. How many more is the key phrase in this? I got to figure out how many more miles Richard walked than James. So if I want to find out how many more of something, I'm going to subtract. So I write subtract right here, so I don't lose my track of what I'm doing. When I subtract, my large numbers always goes up top. So up top, I have 15 decimal 74 minus. And the reason why I put my decimal point here is because when I add or subtract, my decimals have to line up with each other. When I'm adding or subtract, I cannot have a decimal off center. It has to be right beneath each other and numbers filling around. All right, so I got 1, 2, then I got 9, 8. And I'm subtracting. I can't take 8 from 4, so now I got to borrow from my 7. That 7 becomes a 6, and this 4 becomes a 14. 14 minus 8 is 6. I cannot take 9 from 6, we'll have to borrow. So this 5 becomes a 4, and that 6 now is a 16, so this is 7. My decimal point, 4 minus 2 is 2. And of course, 1 minus 0, we get over 0. So now I go find my answer. I got 2.76. A will be correct for this right here. All right, moving along to the next one. It says, after basketball practice, 8 players equally share 3 large bottles of water. What fraction of the bottle did each player get? So now it tells me that 8 players are sharing something. All right, so I got 8 players that equally shared 3 large bottles of water. And I got to figure out what's the fraction of bottle each person got. Now, fractions are huge when it comes to the EOG. They are very huge. Almost 50% of our EOG in 5th grade evolve themselves around fraction. Adding, multiplying, dividing, subtracting, comparing, all that is involved on the 5th grade EOG. So now I got to figure out how much each person got. So anytime I see the terms like this, equally shared, that means I'm dividing something. All right, that means I'm dividing equally shared, split between, each person got the same amount of cookies. Those phrases like that means I'm going to divide. So now I got to figure out what I'm going to divide. So I have players and I have bottles of water. So my players are who I'm sharing with. My water is what I'm sharing. So when I teach division, I teach it when we set our problem up, we use what over who or what divided by who. I use what over who if I'm dealing with whole numbers. I use what divided by who if I'm dealing with fractions. Then if my numbers are whole numbers, I only use this setup of what over who. And I put my equal sign. Now, what is being shared? Well, I'm sharing 3 bottles of water. And who am I sharing that with? 8 players. There's no multiplication involved. There's no adding. All I did was set it up, and my answer is right here. 3 8s, which is C. Remember, if anytime you have to pause the video, please pause it. All right, looking at problem number 4. It says John went to a bookstore. At this bookstore, 3/4 of the books are fiction. Of the fiction books, 1/3 are mystery books. What fraction of the books at the bookstore are mystery fiction books? So a lot going on here, but let's go break it down. We know she went to a bookstore, and in this bookstore, 3/4 of the books are fiction. Of the fiction books, 1/3 are mystery books. So we gotta figure out how many books are mystery fiction books. Anytime we see this word right here, it gave us how many books that were of this genre, and it says of that amount, 1/3 are mystery books. This of related to this right here means we're going to multiply. That means we're going to multiply 3/4 times 1/3. All right. Or we can set it up like this. Because when I'm multiplying, the order I put the numbers in does not matter as long as I multiply correctly. So when I'm multiplying, the setup is not really that important, like it is when I divide or subtract, because regardless if I multiply correctly, I'm still going to get the same exact answer. All right. So in this case, 3 times 1 is 3. And 4 times 3 is 12. When we multiply numbers, we always multiply straight across. Same thing right here. 1 times 3 is 3. 3 times 4 is 12. Now, over to the side, I don't see the 3/12 as an answer choice. That means I gotta have to simplify. Now, how I simplify my fractions, I must find the greatest common factor between my numerator and my denominator. So what I teach the kids is, if you're not sure off the top of your head, come down here and let's make a T-chart. You put the numerator on one side, denominator on the other. All right. Now, what numbers can I multiply to equal 3? Well, 3 is what we call a prime number. That means they only have one set of numbers that I can multiply to equal 3. That's 1 times 3. All right, now we'll go to the other part. We got 12. So I know I got 1 times 12. 12 is a even number. So I know I have 2 times 6. And then also I have 3 times 4. Nothing times 5, nothing times 7. No other numbers I can multiply to equal 12. I teach the kids to go order start from 1, 2, 3, so you don't miss any numbers. So you don't miss anything. That's why we go in this order. Now, I want to find the greatest number that 3 and 12 don't share. What's the greatest factor that they share? Look at this. I see 3 and I see 3 over here. So that's the greatest common factor is 3. So I come over here back to my problem and I divide both parts by 3. And I'm going to get the answer of 3 divided by 3 is 1, and 12 divided by 3 is 4. So my final answer would be 1/4, which is right here. All right, move along. This is a school painted 1/2 of its wall in its gym with 3 colors. Each color takes up the same amount of space on the wall. What fraction of the wall does each color occupy? Occupies understand what they take up. All right, how much space are they covering? That's what occupy means. All right, so let's go through. We know they painted 1/2 of the wall, and they painted it with 3 colors. All right, each wall takes up the same amount of space. There's that same amount phrase that I said earlier, same amount split equally, divided amongst friends. All that means you're dividing. Cool. So now I'm dividing. Now I'm trying to figure out what I'm dividing. This one's kind of tricky because most people think you're dividing the colors. What's really being split up that you're sharing is actually the wall. So the wall becomes your what? The colors are your who. All right, so here's that up again. Whatever who versus what times what divided by who. Being that I have a fraction included in this particular problem, I'm going to use to set up what's divided by who. All right, so now what am I sharing? 1/2 of the wall. Who am I sharing that with? 3 colors. Now I have a fraction divided by a whole number. Before I do anything with this, anytime I have a whole number that I'm multiplying or dividing by a fraction, I must first turn a whole number into a fraction. To do that, we simply draw a fraction bar in place of 1 beneath it. Voila, we just made a 3 into a fraction. I did not change the value of it, I just made it a fraction. It still has the value of 3. Now, when we're multiplying a fraction, there are 2 methods that I teach. The first method is called keep, change, flip. Some of the kids may call it KFC, but it's keep, change, flip. Meaning I keep my first fraction the same. I change my sign from division to multiplication, and I flip that last fraction. All right. So now, using this method, I got 1/2. That's my first fraction, so I'm keeping it the same. I'm changing my division symbol to multiplication, and I'm flipping my last fraction. So instead of it being 3/1, it's now going to become 1/3. So now when I do this method, I multiply straight across. Numerator times numerator, denominator times denominator. And 1 times 1 gives me 1, and 2 times 3 gives me 6. I know I can't simplify because I have 1 as my numerator. Anytime 1 is your numerator, that means you cannot get any smaller. You cannot simplify. That's going to be your smallest answer that you can come up with. All right. So in this case, the answer is going to be D, 1/6. The other method I do is I teach, it's called the butterfly method. All right, so we got the same problem, 1/2 divided by 3/1. Now, butterfly method, most kids like, because what you know is you're multiplying your numerator with the opposite denominator. So this one and this one all grouped together. And this 3 is grouped with this 2, which is probably called butterfly because it looks like butterfly wings or a butterfly band-aid. So 1 times 1 gives me 1. 2 times 3 gives me 6. When we do the butterfly method, your left side always becomes your numerator. The right side is your denominator. So in this case, 1 is my numerator and 6 is my denominator. So I will still get 1, 6. No matter what method you choose, if you do your multiplication correctly or your strategy correct, you still will get the same exact answer, 1, 6. I generally let the children decide what method they like and let them roll with that. All right. So moving on. All right, it says Tracy ran a total of 5 3/4 miles on Saturday and Sunday. She ran 1 5/8 miles on Saturday. How many miles did Tracy run on Sunday? All right, so we know she ran a total of 5 3/4 miles on Saturday and Sunday. We know on Saturday she ran 1 5/8 miles. So we got to figure out how much she ran on Sunday. Well, if I have my total, I know what she ran one day. I got to find what she ran the other, which is Sunday. I got to find what she ran on Sunday. So now, so I got to know what she ran on Saturday, which is 1.58. I know my total. What I'm going to do is I'm going to take my total, 5 3/4, and I'm going to subtract 1 5/8. The reason why I'm going to subtract is I got to find a difference between those 2 days, that total, and that Saturday, figure out what she ran on Sunday. So, in order to add or subtract a mixed number or a fraction, I must have the same denominator. I cannot add or subtract a fraction with different denominators. They have to match in order for me to do that. So what I have to now find is what I call the lowest common denominator. Or you might just call it the lowest common multiple for the denominator. So if I skip count by 4 and skip count by 8, the smallest number they're going to have in common is actually 8. And I'll show what I mean by skip count. So I go with 4, 8, 12, 16, and 20. If I go with 8, I got 8, 16, 24, 32, and 40. If I keep going, I have a lot of different multiples for 4 and 8. But I want the smallest one. And the smallest one that both have is actually 8. So this 8 is now going to become our new denominator. So I'm going to roll my 5 over. And I'll put an 8 right here. And for my bottom fraction, I don't have to change anything because 8 is already my denominator. So I'm going to keep this 1 5/8 the same. Now, this 4 converted to an 8. Well, how did it become an 8? Well, 8 is our least common denominator for our numbers. So to make that 4 an 8, I multiplied it by 2. Whatever I do to the bottom fraction, I got to do the same exact thing to that top fraction. All right, so now I multiply my top by 2, excuse me. So 3 times 2 is 6. Now that I got matching denominators, I can go ahead and I can subtract. When I'm subtracting a mixed number or a fraction, I also subtract my numerators and my whole numbers. You never add or subtract your denominators. So 6 minus 5 is 1. 8 is my denominator, so it stays the same. And 5 minus 1 is 4. So my answer is going to be 4 and 1/8. All right, moving on. It says a sports store has 468 golf balls. They were put into boxes that hold 18 balls each. What is the minimum number of boxes needed for all the golf balls to fit? So minimum, in other words, saying least or smallest. What's the smallest number of golf balls needed to fit all 468 golf balls inside a box if 18 balls go inside each box? All right. So now since I was splitting this right here up into 18 sections, that means I am dividing. I'll put them in 18 groups. So since I'm dividing, now comes that whole phrase again, what over who or what divided by who. Since I have two whole numbers right here, I'm going to use the expression what over who. So what is being shared? The 468 golf balls. What's my who? The 18 balls, because this is the group that I'm putting them in. So 468 goes up top, 18 goes on the bottom. Now, since I have this stacked up, of course my answers are 26, 27, 28, 29. Now what I'm going to do, I'm going to divide. I always divide my bottom to my top. So for division, there's two different ways I teach. We have box division and we have long division. I'm going to do the problem both ways so you can see what the kids may be doing. Most kids now choose to do box division. So for doing box, 18 goes outside. That create me a little box right here. The box is set up so each dividend gets its own separate room. So 4, 6, 8. The numbers always go to the inside of the box. Reason why? Because at some point we won't carry the numbers to the other box, and they're going to put them in front of that particular number. So make sure when you set this up, your number is to that very end line right there and not to the beginning of it. All right. So now ask yourself, can 18 fit inside 4? The answer is no, it cannot. 18 is too big. So a 0 goes up top. If a 0 goes up top, that means a 0 also goes on the bottom. I subtract, and I get 4. All right. What I do now is I take this 4 and I take it to the next row. All right. Now I ask, can 18 fit inside 46? The answer is yes, it can fit inside 46. How many times can it fit? Well, let's skill count 18 to see. All right. So I have 18. I have 36. I have 54. I have 72. I have 90. I have 108. I have 126. All right. And keep it going. I have 144. So there's 1 through 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And then 9 would be 162. All right. So now how many times can 18 fit inside 46? Well, according to this, it can go 1, 2 times. It can't go 3 because 54 is bigger than 46, so that means it won't fit. So it can go twice. So 2 will go right here, and then 36 goes right beneath it. Once again, I'll subtract, I get 10, and this 10 is going over to my next section. Now, same thing applies. How many times can 18 fit inside 108? Well, if we look at my chart, it goes exactly 6 times. 108 goes beneath it. I subtract, I get 0. No remainder. How many boxes do I need to fit all the golf balls in? The answer is A, 26. All right, next question. It says 3 pizzas are shared equally amongst 12 people. What fraction pizza would each person get? Here's that for one of the phrase, equally shared. By now, you should know you are absolutely correct. I'm going to divide this. Now let's figure out what I am dividing. So it says 3 pizzas are shared equally amongst 12 people. Well, my pizzas is what I'm sharing. And my who will be the 12 people. All right. Be careful when you see these. You see how I put the word 3 and not the number 3? Sometimes kids be like, well, what's the other number in? Well, it's right in the word form. All right. So what I'm sharing, who I'm sharing with. Now let's put our phrase together. I'm going to use a what over or what divided by who. Again, I have two whole numbers. So that being the case, I'm gonna use what's over who. What am I sharing? I'm sharing 3 pizzas. Who am I sharing that with? 12 people. All right. Well, I see 312. So the answer choice? No, which means again, I probably gotta simplify. So again, what's the greatest common factor between 3 and 12? If you said 3, you are correct. I can divide both parts by 3 and get a smooth number. 3 divided by 3 is 1. And 12 divided by 3 is 4. Answer will be C, 1, 4. All right. Once again, if you have to, please pause this video anytime, rewind it, go back, look at it again, make sure you get all these steps. All right, next question, it says, what is the value of the n in the equation 2/3 plus n equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In other words, 2/3 plus n equals 10 over 12. First things first, let's label our figures. All right, so this is 2/3. I know it's 2/3 because 2 parts are shaded in, but it's 3 total parts. Same scenario here, this is 10 over 12. All right, so now 2/3 plus n equals 10/12. This is kind of like the decimal problem we had earlier when I had to find the difference. Anytime it gives you an adding problem, and you gotta find a missing number, you always want to do the opposite operation. So the opposite of adding is subtracting. So what I'm gonna do is I'm gonna take my answer, which is 10/12, and I'm going to subtract 2/3 from it. Once again, in order to add or subtract a fraction, I must have the same exact denominator. So between 3 and 12, what's going to be my least common multiple? All right, let's go and skip count. So I have 3, 6, 9, 12, 15, 18. If I go by 12, I have 12, 24, 36, 48, 60, 72. Which is the smallest they have in common? 12. Now, there's another one that can go on and on for days and days, and they have plenty in common, but I want the smallest one. All right. So then this is already 10 and 12. So I don't have to change this first fraction at all. I can keep it as is. All right. But the second one I got just to work to. I know my denominator has to be 12. So I have to multiply this 3 by something to get 12. So what is it going to be? 3 times 4 equals 12. So whenever I get to the bottom, the same thing again is done to the exact top. So multiply this top by 4 also. So 4 times 2 is 8. So now I go to subtract. Remember, I never ever subtract my denominators or my denominators. I always subtract my numerators, and if I have mixed numbers, I subtract my numerators and my whole numbers. So in this case, since I got regular fractions, I'm only going 10 minus 8, which is 2. And I keep my denominator the exact same. Over here, let's see which one would equal 2/12. Well, this only has 6 parts. This only has 5 parts. This is 2 separate figures. Let's simplify. What's the greatest common factor between 2 and 12? If you said 2, you are correct. And I divide both parts, I get 1 over 6. Now, does any answer choice equals 1 over 6? If you said A, you are correct. Because I have 1 part shaded in out of 6 total blocks. What fraction will B represent? If you said 4/5, you are correct. What about C? I have a whole block here and part is shaded. What is this equal? If you said 1 whole and 1/3, you are correct. And for D, again, another whole and part of this, if you say 1 and 1/2, again, you are correct. All right, so but the answer for this choice is A, because it equals exactly 1/6. All right, last one we're going to do. It says Mr. Edwards bought a 50-pound bag of flour for his bakery. It was equally divided among 6 days. How much flour was used per day? All right, so you bought this 50-pound bag of flour. That seems to be important for his bakery. It says it was equally divided among 6 days. Well, if something is equally divided, that means I'm dividing to solve my answer. All right, there's that phrase, equally divided. It's going to stand out like a sore thumb. Divided fractions are very heavy in 5th grade on the 5th grade EOG. So we got to make sure we get this standard down pat, because if not, we're going to struggle trying to pass. All right, so now I know I'm dividing. Now I got to determine if I'm doing what divided by who. And also determine what is my what and who is my who. So what is being shared? Well, the flour is being shared. That becomes your what? Who am I sharing that with? In this case, I'm sharing my flour with 6 days. That's my who. Then I have whole numbers, 50 and 6. I'm going to stack them up and do what? What again is my share? I'm sharing the 50-pound bag with 6 days. Do I see 50 over 6 as an answer choice? I do not. But I know one answer choice is not going to be correct, and that is A. The reason why I know it's not A is anytime I have an improper fraction, and an improper fraction is where my top number, my numerator, is bigger than my bottom number, the denominator. In this case, I'm going to have, when I convert this, I'm going to have a mixed number. So I know it can't be A, because A is just a regular fraction. That cannot be my answer. All right? So now, when I have to convert my improper fraction, which is what this is right here, and your students should be able to tell you what an improper fraction is. If they don't, let me know. All right. So now I want to convert this into a mixed number. How I do this, I take my numerator, which is the top number, and I divide it by the denominator, which is a 6. Can 6 go into 5? It cannot. Can 6 go into 50? It sure can. It can fit 8 times. And 8 times 6 is 48. I subtract, I get 2. This 2 says there's nothing to bring down becomes my remainder. Now, how could I mix numbers together? Everything outside the house and at the front door goes into your mixed number. Here's your roof, here's your front door. Anything before the remainder is always your whole number. In this case, this 8 represents your whole number. All right. The remainder always becomes your numerator, and your divisor, what's at the front door, always becomes your denominator. So using that rule, 8 is my whole number. My numerator is 2, and my denominator is 6. So I have 8 and 2, 6. Do I see this as a choice over here? I do not. But I also know I can eliminate an answer, which is D, 300. It's not a mixed number, and it's way too big than what I got right now. So now I probably have to simplify this. So when I simplify mixed numbers, my whole number is going to stay the exact same. So I'm going to drop my 8 down right here, because that's not going to change. You don't simplify whole numbers. But between my 2 and my 6, what's likely the greatest common factor between 2 and 6? If you say 2, again, you are correct. So I divide both parts by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So I have 8 and 1/3, and my answer choice is right here. These are just some simple problems that children may see on the integrated test this year, or problems very similar to it. Please, if you have to review this over and over again, have them listen to it, have them follow along and do it with me with their pencil and paper. So see if they can pause it, see if they can get the correct answer or not. All right. Repetition is key to learning. You must do things over and over again to learn. I hope you enjoyed it. Hope it was helpful. Hope it was insightful. As always, stay safe and take care, and I'll see you next time.